Trudy, thanks so much, and thanks as well to Joel to both of you for inviting me to do this at the end of the meeting. I think it's and now for something completely different is what this is. Instead of swamping your intellect with data and equations and beautiful simulations, let's talk about our craft together as journalists and what all of the talks that you have heard here might mean for your stories down the road, what sorts of things perhaps you can do from this meeting. And what I want to do for these first 20 minutes or so is to establish a possible framework for a roundtable discussion among all of us, not only the 21 participating journalists and science writers, but also the scientists who are still here. So a word of warning, this will be by far the lowest tech PowerPoint presentation that you will have seen in the last 2 days. I'm the only speaker, I think, with a bachelor's degree, so advanced PowerPoint is above my pay grade, so apologies for that. This is actually a little scene from our graduation ceremony in the science communication program. I put this up here just to make the graduates of the BU program, the MIT program, and the NYU program jealous. This is not the sort of thing that you see on the East Coast. And Lisa Grossman, in fact, will recognize that these are her classmates. This was the graduation ceremony for her year in June of 2009, 3 years ago already. So let's see if this will work. It does. I think we have, as science journalists who write about astronomy, physics, astrophysics, cosmology, planetary science, and so on, we have a built-in advantage over many journalists who write about other fields, which is that it's been my experience that stories about astronomy really command a rapt audience. And I think there are several reasons for that. One is that despite what you might think about childhood education and the sciences, I think we still do a good job at conveying the notion that our solar system is our home as a race. Earth is part of a family of planets. I think kids emerge with that idea very strongly, so they like reading about our home in the Milky Way galaxy. The Milky Way specifically and galaxies in general are beautiful. They are just lovely geometrically. They have a pleasing symmetry for the most part. This all helps with visual presentations of stories about astronomy. Extreme astrophysical objects just rock. Okay? Black holes, neutron stars, gamma ray bursts. Black holes are one of the few astrophysical objects that you can count on as being really high-selling cover stories in periodicals, for instance. And then cosmology, as we know from Joel and Nancy's experiences, simply compels us fundamentally. It's a topic that just has near universal appeal, as does the prospects for life, whether it be of the ET variety or of the slime variety, really compels or holds universal fascination. Now, this is actually a good and a bad thing for us as science journalists, as we've heard a little bit of murmurings during some of the previous Q&A sessions in the last 2 days. Many editors always want you to say, well, what does this mean for, is there life on this extrasolar planet? We get kind of tired of answering that question, but frankly, the readers out there will want to know continually. We have to deal with that. Okay, so as an example of just how widespread and best-selling some of these concepts can be in a publication sense, Smithsonian, a magazine for which I write, does very few special issues. This was one of the special issues that they did at the end of 2010 called Mysteries of the Universe. I neglected to bring a hard copy with me, but this is from the website of that special issue. We can recognize many of the images that we've seen at this meeting. This was from a cover story that I wrote in Smithsonian about the supermassive black hole at the center of the Milky Way, for which I went to Mauna Kea to see the adaptive optics system in action at Keck, which was a truly spectacular experience. We've seen this image, we've seen images like this one, we've seen images like this one. Another example of this, National Geographic, which also does a number of special issues from time to time. This was an issue on space, which came out about 4 years ago. They're doing another one coming out in July. I was fortunate enough to be asked to write essays for both of these special issues. These on the newsstand sell like hotcakes. So we have that going for us. Now, that doesn't necessarily translate into fantastically compelling stories about astrophysical simulations. I think that's another challenge above and beyond the aesthetic type of stories that I'm talking about here, and that's what I want to get into with you in the roundtable. So simulations add a level of explanatory complexity. There's no question about that. Here are some of the ways in which they do. Frankly, computer science as a field for science journalists is very difficult for us to delve into because the eyes of readers simply glaze over. Computer science is really difficult to make a compelling topic. Donna Husterman has firsthand experience with this from a magazine story that she wrote for our program. Supercomputers, in my experience, experiments that happen entirely in silico, simply they're harder to convey conceptually. Readers just don't get them as well. And the believability aspect, which I'll come to in another bullet point, comes into play here. Simulation stories necessarily need to become quantitative in order to really do justice to the scientific results. Okay, these are very mathematically detailed, obviously. As they get more and more quantitative, editors get more and more nervous about running such stories roughly in linear proportion, maybe even in exponential proportion. Equations scare the readers of many outlets unless you're writing for a place like Physics Today, where you probably still want to limit them as much as possible. And then many simulations are dazzling, but as we've heard time and again, why should readers believe them? So I think these are some of the topics that we can consider as a framework for our discussion together today. So let me, before I get into that, I do want to say this is one thing that the supercomputer simulations do have going for them very strongly, is that we now live in a very visual media environment. There's no question about that, with the profusion of online news sites. And the more beautiful you can make your story look aesthetically with multimedia accompaniments, the more likely it is to gain a large and cross-cutting audience. So simulations such as of space weather, which clearly affect all of us directly, of supernovae and black holes and anything involving general relativistic simulations are intrinsically fascinating to audiences. The first stars and galaxies and large-scale cosmic structure, both of these latter two in an origins sense. I think these images and movies can really help sell your stories to editors and assuage some of their concerns about the quantitative complexity of them. Okay, so this slide will list what I've come up with as 5 possible talking points for our roundtable. And I'm going to put this slide up again at the end. And I'm going to just take a couple minutes on each of these points with some additional slides. But here are things that I thought we could talk about together as a group. And of course, we don't need to limit it to these things. We're storytellers. Telling stories about the research that you've heard here in these last 2 days is your challenge as science writers, not simply conveying a set of results. You want to delve beyond just showing the pretty pictures. There are scientific narratives here. There are incredibly rich scientific narratives here, foundational ones about our understanding of the place in which we live. There are also personal narratives. And I'm going to show you in a couple of examples of where that can come into play in successful storytelling about scientific research of this type. Another part of our major challenge is using metaphor and accessible analogy from your sources or that you devise, and this is your task as a trained science writer, to come up with metaphors that are both accurate, to do justice to the science, but also help your readers visualize the processes that you're trying to describe. And I'm going to show you a couple examples of those. We need to recognize as journalists that not all of these stories will work for all audiences. So you need to keep your readers in mind for your specific publication, or if you're a freelance, for the range of publications for which you write, and determine the level of complexity that your readers are willing to follow along with you. Be skeptical of BS, and I'll have more to say about that. And finally, I want as well to talk about the role of institutional press officers, because that's something that came up yesterday, and I was approached and said, let's talk about that a little bit. And as a former press officer, I can contribute to that conversation as someone who's been on both sides of that divide. Okay, so the first bullet point, storytelling. Scientists are people too. Readers like that. Readers like characters involved with stories about complex research, so that they know it's not just, to use the UK expression, boffins preaching from on high. Okay? There are people who have devoted careers to this work. It's deeply meaningful for them. Let's find out as journalists why it's deeply meaningful for them and try to tell those stories. So my first two bullet points are directed to the scientists who are still in the room. In order for this to happen successfully, the researchers need to be available to the reporters more than just a half-hour phone call answering questions. So it's a two-way participatory process, and if you really want a thorough, well-told story about your research, you need to be willing to spend the time with reporters who are, by the same token, willing to come and spend some time with you at your research site. I love talking to scientists who are capable of conveying why this research matters to them, and who can explain or give an answer, a satisfactory answer, to the question, why should it matter to us, to our audiences? And if your scientist is not taking the time to do that, you need to push them. You need to ask them specifically with questions that you can phrase in different ways, depending upon the context. Journalists, take the time to ask your sources for their anecdotes, their frustrations, their stoppings and startings, their trials and errors. These are the questions you need to ask in order to convey science as a process, not as a series of eureka discoveries. Okay, and this is what I mean by scientific narrative. And their revelations. Okay, there are wonderful moments of discovery. Okay, we heard Mike Norman talking about what he feels it means to make a discovery doing in silico experiments. And when he and his team find out, or when Tom Abel finds out, those first stars may very well have been 300 solar masses or 1,000 solar masses. Find out what that moment of revelation when they were looking through their data really felt like, even though it might not be true. And always keep your audience in mind. So certain publications and certain editors are going to expect more storytelling than others, and also it critically depends on the type of article that you're writing. A 500-word article versus a 3,000-word article, you can clearly do very different things. Okay, so just one example of this from my own recent experience as a journalist. I wrote about the Solar Dynamics Observatory for Smithsonian. which was on the cover of that Mysteries of the Universe compilation that I showed you. This is Carl Schreiber, who is a solar physicist who works at the Lockheed Martin Solar and Astrophysics Lab in Palo Alto. And he's sitting in front of a small version of the hyperwall that you're going to be seeing at Ames tomorrow. This is a conjoined set of 9 high-definition screens deep inside the Lockheed complex, which are capable of displaying in film quality the data downloaded from SDO at absolutely stunning rates. They're basically taking a full sun image every 10 seconds, and they can play them in movies. And Carl, who has been working in solar physics for, I think, 23 years now, gets positively giddy when he shows these movies to visitors. And when it's such a leap forward by more than an order of magnitude over any other solar data that has been available previously, both in terms of resolution and temporally, time step-wise. And Carl, there's his affiliation. He went on with me. I had my recorder running the whole time, and he was probably the most quotable scientist that I've interviewed in recent years. And one of the things that he just said when he was showing me a simulation, which looks, or not a simulation, real images, which look like what's behind him. When we show these movies to our colleagues for the first time, the professional expression is generally, whoa. And I mean, it was such a moment with him in the room. And this is in the context of a much longer excerpt from our interview that I included in Smithsonian, that it just jumps off the page at you. You just understand how wonderful these research experiences are for these scientists who've been waiting years, or in cases decades, for these new sorts of space missions to be able to see the universe with a full set of eyes, finally. Okay, moving on to metaphor and analogy. I think for the kinds of research that we've seen here in the last couple of days, finding things that work for your audience in an internally visualizable fashion is just essential. So, for instance, there are universal laws of physics. You can draw upon familiar comparisons to help your reader understand how a physical principle in the distant universe works in comparison with something that they're more familiar with at home or within our solar system. I wrote with Neil deGrasse Tyson and Charles Liu at the American Museum of Natural History about a decade ago, a book revolving around this entire concept. The book is called One Universe. It's basically full of physical principles on Earth and within our solar system that we can then apply to understanding the distant universe without having access to that distant universe except through our instruments. So look for those. Ask your scientists for those comparisons directly. Many of the researchers will already have thought along those lines. Others will have not, but you can push them in that direction and see what they come up with. Help your reader visualize. Greg Laughlin came up with this absolutely wonderful little nugget in his talk yesterday about the dark interstellar cloud. And we saw that same cloud this morning in another talk. And he said to picture the density, the real physical density of this cloud. Imagine taking a single grain of sand, crushing it up uniformly, and spreading those particles throughout a sphere a half-mile in diameter. When your scientist comes up with that, that's absolute gold. I mean, I can tell you that I would use that in a heartbeat if I was writing about these objects. It's relatively rare that a researcher is going to be able to talk with you in those terms. And I can tell you that one reason Greg did that is that he writes for public audiences frequently. So he's used to thinking in those ways. Okay, Joel is also excellent at that because he's been thinking along these lines for decades. If they don't come up with it, or if they can't on the spot from a directed question from you, then that's your task as a science journalist to come up with a comparison like this, which will be meaningful for readers. Might an earthly process be relevant? Okay. Some years ago for Science, I wrote about these phenomena beneath the surfaces of neutron stars called superbursts, which are periodic thermonuclear explosions that burn a much deeper layer of the neutron star than they usually shed. So there are regular bursts, and then there are these things called superbursts. And it occurred to me that the process was very similar to what happens at the Steamboat Geyser in Yellowstone. Steamboat Geyser, for those of you who don't know, is a geyser that has periodic eruptions that are 5 to 10 meters tall. And then every so often, every few years, it unleashes a 100-meter tall, gigantic eruption that somehow taps a deeper layer of the geyser hydrothermally and empties it out all at once. So I used this in an article for Science called Ashes to Ashes, The Inner Lives of Neutron Stars. And this was an artist's depiction of this process. And the text, which you can't see in that captured PDF file, these are just the first paragraph and a half, which basically goes through what I just described for you, 5 to 10 meters high, years to decades, 100-meter column, deepest, hottest water. Similar outbursts happen in space. Astrophysicists have learned powerful and unpredictable flares of energy, given the geyser-like name of superbursts, strike beneath the surfaces of a few special neutron stars. At this time, this was in 2002, they only knew of 7 of these things. So this withstood the scrutiny of my sources. I sent it to them to make sure that they were comfortable with this analogy. This withstood the scrutiny of my editors at Science. And this ended up being my first Schramm Prize award-winning story. And this is not something that anyone had suggested to me. I just in dwelling upon this phenomenon and in trying to apply the principles that I did in the book with Neil about using earthly relevant processes, I came up with this to help readers visualize this periodic process of tapping into something deeper and basically burning through a much deeper level of explosion. This is the heart of explanatory science journalism. And it simply takes time to devise these. And if you can come up with a scientist who will help you do some of that work, then that's great. OK. The next step, not all stories are suitable for all audiences. Another way of saying that, don't explode your readers' brains. Recognize how far you can take the conceptual level of your story based on the audience for that particular publication, that website, that magazine, that online news service, and so on. Now, what I've done here is to list in descending order of complexity in terms of conceptual level, roughly a dozen of the organizations for which I've written over the years. And as an interesting mental exercise for you would be to think about the places that you write for and where they would fall along this spectrum. So at the top is this Department of Energy publication called SIDAC Review, for which I wrote a 5,000-word, very detailed explanation of why supernovae explode, which involved a huge amount of the types of simulations that we've talked about here over the last 2 days. Because as you may know, it's really difficult to explode stars in computers. And that went into a lot of detail. This is basically for an audience of specialists. Moving on, I've written for Physical Review Focus, which is an APS online publication that focuses entirely on papers published in Physical Review Letters. And then for Sky and Tel and Astronomy, read basically by astro geeks who love going into detail, even if they don't quite understand all of it. They still want it on the pages. I was a I was the US correspondent for Science for about a decade. We were told at Science to try to keep our articles understandable for life scientists, even if we were writing about the physical sciences, which is why I put it below Sky and Tell, because at Sky and Tell, they don't care whether a biologist can understand it. But at Science, they want that. And then Scientific American is now using more and more contributions from journalists, and they want these journalistic feature articles to be accessible at more of a level than Science. New Scientist, for which Lisa writes, is a bit more accessible than that. The other issue with New Scientist, which is part of this conversation, I think, is it's not just how far you can go conceptually in terms of the complexity of the subject matter, but it's also how speculative are your editors willing for the articles to be. Okay? How concrete of a discovery and vetted by the rest of the community does it need to be to appear in the pages of New Scientist versus Science? Those are completely different, poles apart. Okay? You see lots of things in, okay, I'll go out on a limb here. 90% of the things in New Scientist are not true. In terms of feature articles. Okay? I'm primarily a feature-length magazine journalist. Discover, National Geographic, Smithsonian all form kind of the next part of the spectrum. Smithsonian, my longtime editor there, who was also a graduate of the Santa Cruz program, basically told me our readers are scared of science. So that's the conceptual level that I always needed to keep in mind when I was explaining processes. So it's a recalibration from here to here. And then the Chicago Tribune is where I started. The LA Times would fall in the same part of the spectrum here, where you might be assuming kind of a high school level where they're maybe interested in it. And if you keep their interest long enough, they'll stick with you through the end of the article. But you're not going to go beyond a high school physics class. I've written for Muse, which is a Smithsonian publication that's aimed at ages 10 through 16, and then Highlights for Children. So if you look at this spectrum, I would say that if you compared this to the electromagnetic spectrum, we're going from X-rays to radio. It went here. And this is one of the wonderfully satisfying parts of being a science journalist is successfully reaching all of these different communities. But it really does take a total internal intellectual recalibration of conceptual level that you can go into, or else you risk exploiting their brains. So above all, whatever you do when you're figuring out how far you can go conceptually, whatever you do, please avoid plasma magnetohydrodynamics.
That's getting harder sometimes.
Yeah, this is a little bit of a joke because this has actually been my own explanatory bugaboo over the years. I have a really hard time writing about this. It's refreshing to hear Joel say, it's just damn hard to do scientifically as well. But in terms of earthly comparisons, almost nothing has a semblance of accuracy or verisimilitude to work when you're trying to explain these processes. So it's not only avoiding this 8-syllable word in any article that you write, but conceptually, it's just really, really hard to go here. And this is something I want to talk about in the roundtable, I think. But this is gastrophysics and simulations, which are trying to do a lot of that. I mean, we've seen over the last 2 days that's at the heart of some really forefront stuff in the HiPACC consortium. How the heck do you write about that? It's a challenge. OK, BS, I'm using this in 3 different ways. As journalists, I think it's so important for us to be skeptical. to use our BS detection meters. Okay, I won't use the actual word there, but you know exactly what it is. But also to use your Bachelor of Science degrees, or for some of you even more than that. I did a quick look through the program. Probably 2/3, and there's some data that's not available in the bios, but probably 2/3 of you have science training at the college level, either as a minor or as a bachelor's degree, and several have gone on, master's, PhD. When you have that training, use it. Now here's what I mean by that. It's so important, I think, for us in this day and age to eschew single source stories and to always check with others in the field who are not part of the research team. So within this cozy little HiPACC family, there are points of view, maybe some different points of view, but not as different as if you go and talk with the Europeans about their simulations. And I'm kind of guessing that Simon White's reactions to Joel's statements 45 minutes ago would be interesting. Ask challenging questions. Don't take their word for it. Okay, use your training to really delve into how they arrived at particular conclusions. Draw upon your own training to act as knowledgeable gatekeepers. Now, here's what I mean by that. When I worked at Science, or for Science, I read AstroPH daily. I read the abstracts. I was acting as the gatekeeper for the magazine to determine what astronomy coverage went into the magazine from week to week and month to month, because I had a level of knowledge, because of my training, even though it was only at the bachelor's degree level, beyond that of the other people at the magazine, to determine which stories to write about, using both news sense and also using my own built-in BS detector, because we know there's a lot of stuff on AstroPH, because it's an open archive, that simply doesn't cut the mustard. Shoot down crap. Okay? Now, collectively, our informed journalism enterprise can self-correct more quickly now than ever before. And we've been seeing this in action a lot with stories that never should have seen the light of day in the first place. One recent example was this whole episode revolving around arsenic-based life forms. Okay. So that got shot down within hours, and then quite in much more detail after that. So use your training. Now finally, the last point that I wanted to just lay the groundwork for our conversation revolves around journalists and institutional press officers and the relations between the two. High caliber public information officers are wonderful resources. Get to know who they are. Several of them are here. Many of them attend meetings where the major news within the field is released. So I could know that if I went to the American Astronomical Society meeting as a journalist, that I could get absolutely reliable information on issues within radio astronomy from Dave Finley at NRAO, because he's just a total high caliber professional. Subvert journalism. Do your own reporting. Journalism means taking a press release and just plopping it up as a news story, barely rewriting it, and passing it off as vetted news when it's not. So going back to the previous point about seeking outside comment, that's what I mean by subvert journalism. Sadly, there's just too much of this going on now. It won't come from any of you, but always resist that temptation and use news releases as resources for your additional reporting. Recognize that agendas do exist. Okay, so there was a little bit of prickliness. I think what Greg was trying to get at yesterday was that there are instances where news releases are put out by institutions for a reason. Okay, I'll give you an example. Cornell University in recent years has put out a great number of news releases about the scientific discoveries of the Arecibo radio telescope. The agenda there was that Arecibo was going to lose all of its funding from NSF. That was the reason why there was this massive wave of press releases over a 2 or 3 year period from Cornell about discoveries using Arecibo. There's no sugarcoating that. It does happen. So you need to use that BS detector that I was talking about to find out when that's true. That will not be the case from the high caliber research news offices around the country, for the most part. We're seeing more and more scientist-issued news releases. Be wary of those. They haven't gone through the campus press office. It's coming directly from the scientists. They have their own things that they're trying to promote. A recent example of this, not in astrophysics, was this absolutely horrible thing. I forget the meeting that it was issued at. I think it was, I can't remember the meeting. Somebody found fossils, or he said that it was evidence of a cephalopod that had self-awareness and was arranging images of itself in this fossilized thing that they found on the seafloor. It was a Kraken-related story. I don't know if you remember this, just a few months ago. But that came from the scientist. It did not come from the institution. The scientist issued that news release at that particular meeting. And then I just want to put this up there, something I think we can talk about. But NASA is the 800-ton gorilla when it comes to institutional announcements about astronomy. And they obviously have an agenda too. A lot of it is incredibly useful, fantastic resources, obviously, wonderfully public archives of things from Hubble and so on. A lot of it is stuff that should not be given the time of day. And you just need to apply your own gatekeeper sense to recognize that. OK, so this is my program, scicom.ucsc.edu. This is my favorite logo, if you haven't seen this one, of the Fiat slug. And I will put back up on the screen these possible talking points that I just went through, all 5 of them. And at this point, I would like to now, for the next 50 minutes, open it up for discussion, which I will moderate. I don't think we need to rearrange. I don't really want to take the time to do that. It's a small enough room where we can see each other, turn around, and see who's talking and asking questions. But any of these topics or things that you would like to bring up beyond this, let's start having a discussion together.
So I work for CNN.com, and basically my bar of success is a headline. If I don't have a good headline, the headline is not on the homepage, and no one sees the story. Now, I can put up as many stories as I want, but no one will ever see them unless it can fit in about 40 characters. And that's a huge problem when you're dealing with topics as complex as some of the things that we've been talking about. And I was wondering if you had any suggestions, or if anybody has suggestions for, like how do you make a really sexy headline in a finite number of characters that is also accurate?
Yeah, I mean, that's even a worse problem than Twitter, right? So 40 characters instead of 140. Wow. Yeah, that's tough. That's tough. Who has some thoughts about that? But it is undeniably important, especially because of search engine optimization. Yeah. Who has some thoughts about that?
Does it have to be all that accurate?
Can't be wrong.
Not if you put a question mark at the end. That's how we get around it.
And I wonder,
You don't want any title that the scientists you talk to can come back to you and say, what the heck were you thinking with that title?
Right.
So that would be the bar.
Mm-hmm.
I wonder what the scientists in the room think of when their work is written about. Like if you take issue with the headline, who cares?
Well, I mean, I think the headline, and since I'm a scientist, I think the headline is there to get people to look at the article. Like, some kids will take a little bit of liberty. I mean,
know a lot less than the reporter about science.
Editors,
That's the thing.
Sometimes the headline actually contradicts the story.
Yeah.
yeah.
It's happened to the best of us, believe me. It's just, and you feel like horrible, and there's nothing you can explain this.
I mean, there's a range of editors out there. So Camille's editor, knows a great deal about astronomy. He's been in the field for decades. And if you're writing for a general interest publication or for CNN, that's likely to not be the case. And then it's really on you. I mean, I think I always wrote headlines for my own copy, regardless of for whom I was writing. And more often than not, they were adopted. So I think you can take some control over that and bounce them off of your roommates and your family before you submit them to your editor and see what catches people's fancy without being sensationalistic. Alliteration is always good.
Yeah.
Okay, what other topics can we bring up? Yes?
Well, the skepticism, sorry, it's been a long day. The skepticism issue and the BS thing, I think, is a big one, and something that science journalists are always talking about amongst themselves. And I think there's a tendency among science journalists to be sort of boosters for science, which is a hard thing to, it's a thing that we have to grapple with and to sort of, it is very hard to be skeptical. It's very hard to be objective about these things that we're writing about.
I agree. The tendency is to cheerlead, especially if you yourself have a science background. I think that tendency is actually even heightened a bit. And we fight it in our program. Sometimes the best way for the students to learn about that is through painful experiences, by being burned when they report on something that is fairly quickly refuted. This happened just a few months ago with one of my students who was writing for Wired.com about this guy who claims that he could do human flight with wings that he attached to his arm. Do you remember seeing this coverage? Okay, well, it got way too credulous coverage for about 6 hours, including my student. And there was a video that was later shown to be doctored, and the person who did it admitted that it was a hoax, showing him running along a grassy strip and then taking off by flapping. And it was reported credulously by Wired.com and a number of other news outlets, and then a bunch of bloggers said, what, WTF, and went into the video and basically showed this is inconsistent, this part of it is not physically plausible, and it all got retracted. So now she knows. Start asking hard questions before you run with the story.
So, well, sort of to build on that, I'm wondering if you have any sort of suggestions, specifically in the field of astronomy, where it's such a small field, and we're constantly counting on the same people whose work that we're covering to be our outside sources on other stories. And
yeah.
It's very hard, especially if you're going to AAS conferences or things like this. You develop these sort of collegial relationships with researchers, and it's very
They can only be so collegial.
Yeah.
I mean, it's a small community. It's not a super small community. I mean, a good-sized AAS meeting has 3,000 people. You absolutely want to cultivate reliable contacts. I mean, I had people in star formation, people in supernovae, people in planetary science that I knew I could call on and consult with them and get the straight answer without necessarily even quoting them or using them in my story, just using them as sounding boards. And those are the sorts of relationships that take years to cultivate. And I also find that you really have to do it in person by going to both small gatherings like this and the big national meetings and getting to know them outside of a formal telephone interview situation, and then learning which ones are the golden ones to come back to.
And another thing that helps me is
joke about the slide with unanswered questions, so we should all remember those questions and then look when we encounter a press release or a paper and say, is this asking one of those big important questions?
Is there a reverse danger to that where we're always tying a story to a bigger, more
You can always feel like the same
I feel
story,
like,
all the
yeah,
water.
like when you're like pedaling almost, like, oh, this is important because of this big question. How do you find that balance?
Yeah, the nuance can get lost, especially in rapid-fire online news reporting, and that's where it takes, longer form journalism is where you really get into context, where you get into the historical narrative. Synthesis stories take time to report.
We want our stories to be important and interesting, but if they're not important and interesting, they can still be.
Yeah, and I mean, my own pet peeve about a lot of astronomy writing that I see now, and I think this is worse now than it was in the past, is the over-reliance on superlatives. The farthest, brightest, most powerful, biggest. I'm so sick of most distant galaxy stories. I'm absolutely sick of them. And yeah, and like the next most distant galaxy is 0.01 in redshift farther than the previous one. Okay, don't care really that much anymore. We get the point. We're looking back close to, the original epochal objects. That's the concept we need to convey, not that it was 13.14 billion light years away.
So what's the turnover point when it stops being, here's the most Earth-like exoplanet yet, and starts being like, oh my God. No.
I think we've gotten to that point with exoplanets.
Well, totally, yeah, but like,
yeah.
I don't know. Is that just like?
I mean, it's a critical mass phenomenon. I think it's a community recognition phenomenon among journalists, akin to the phenomenon that happened 12 years ago, where people reporting about climate change realized we no longer need to quote the 2% skeptics in every single story about climate change because it's not doing justice to the consensus, and it's portraying a wrong message to the readers. So now in exoplanets, there are, I think, enough plausibly habitable worlds out there that we don't need to say that every single damn time now. We don't need to announce every new dozen batch of planets. Okay, Kepler's finding them by the scores. We don't need to announce them all anymore.
Rob, something you just said reminded me of a problem in virtually all reporting on the early universe or the distant universe. Let me just explain something that all people who report on astronomy need to know. And that is that if we see a galaxy right left, say 13 billion years ago, it is not 13 billion light years away. It's probably about 20-some billion light years away. We can't measure the distance. It's not something that we can measure. We measure the redshift. That can be measured precisely often. We have a good spectrum, we can get the redshift. We can convert from redshift to distance using standard cosmology. And if you want to learn how to do it, the simplest thing is look up Ned Wright's Cosmo Calculator or get CosmoCal, the free app for the iPhone.
I use that all the time.
Okay, they're accurate. Do not say that a galaxy whose light left 13 billion years ago is 13 billion light years away. That is wrong. And it conveys wrong information. There's just no reason to ever say that.
But other than that, Joel, does it bother you?
Yes.
Okay. I wasn't sure.
Oh, I noticed this too, but you know what I say? Who cares?
Well, because sometimes people report it correctly. The fact is it's just wrong.
It's wrong, but who cares?
Well,
We
because
care if we're getting it.
Oh,
wrong.
yeah, accuracy.
But you can just care, you can say, when I interpret, they say 13.7 billion light years away. It's actually good. CMB is like 46 billion light years
that's
away.
correct. It's about 40. So here's
But
the
I
stuff
interpret
that
that.
radiated the cosmic background radiation is now about 46 billion light years away.
Joel,
What radiated that was about 46 billion light years away.
But Joel, This is the point where I would argue that for all but a very small minority of readers, this is the head exploding conceptual level. Okay? It just, you can, right, it's a matter of precise phrasing. And that's where, so I don't know how you all feel about showing copy to sources. Okay? There are different standards, and let's talk a little bit about that. There are different editorial review standards at different publications. It's science, which employs no fact checkers, none. We were responsible for the accuracy of our own copy totally. I had no problem sharing my entire stories. I'm sure I did this with you many times, with my sources, with a preface note saying, I want to get this right. I want to make sure there aren't any errors of fact. Please review this for accuracy. For accuracy, a very, very carefully worded message. If they then try to change a quote of theirs, or they tried to take out an adjective that rubbed them the wrong way, I felt free to ignore that. Okay, I was asking them to check it for accuracy. Now, I was perhaps more comfortable with this because of my decade at the UC Santa Cruz news office, where, of course, we had to share everything with faculty. That's just de rigueur if you're working at an institution. But people who are professionally in the newspaper business, you would never do this. Okay? More and more newspapers are okay with you reading back over the telephone a passage to one of your sources to make sure that you get that wording right. Now, at other publications, at both Discover and Smithsonian, I am forbidden contractually to share any text with my authors. It's done completely by the fact checkers, although this may have changed at Smithsonian now since they fired all their fact checkers. But at Discover, this is certainly the case. At Scientific American, National Geographic, this is certainly the case. So for my 3,000-word article for Smithsonian on the supermassive black hole at the center of the Milky Way, I had to write a fully annotated manuscript indicating where I got every single factual statement and give that to the associate editor. That annotation for a 3,000-word article was 4,500 words long. It's an incredibly laborious process. But these editors care about getting the details right. And then they check everything with the researchers, but they don't share the entire articles. Right. They just call up and say, is this right, is this right, is this right? So there's different ways of doing it. But if you're responsible for it on your own, if there's no fact checker that you can call upon, I think, even though it violates the tenets of some people in the daily journalism business, why not share it with your sources with that preface note, I want to get it right. Earl? You don't have to, right. Yeah.
This is the point. I just wanted to comment on your statement that the rules of the road at institutional press offices are to absolutely send it back. And the truth of the matter is there's a spectrum there in individual press offices, in institutional press offices, as there is within the media. Bob Byers at Stanford for years, Joel Shurkin, who was on his staff, specifically, I remember long conversations where they never shared
Well, in this,
Just as varied.
yeah, I thank you for that. And in this era of marketing and institutional branding, we're seeing more and more of a drift towards that, rather than the news office model.
That's exactly, and that's why I'm now soon to be enjoying my retirement after 34 years. But the other kind of caveat to that, which really raises I think an important question, is with the advent of the internet now, there's not an institutional news operation that is not directly feeding its stuff to the public via the web. And Google News and Google search engines incorporate all of that stuff. Eureka is pulled off of that. Newswise releases and things like that go into the same pot that conventional media information goes into. So the orientation is kind of in many research universities shifted way beyond news over into marketing and communications and push communications and things like that. But at the same time, the availability of that information to go out has, the checks and balances have all vanished in that way. So in a sense, what we're getting is a smaller and smaller cadre of really trustworthy news officers at institutions, just as we're having a smaller and smaller cadre of staff science writers at all sorts of media. So kind of leaves us with a questionability on the copy that we see every day from everywhere.
I agree. Yeah. Trudy?
Spectrum, IEEE Spectrum, it was Spectrum's policy to send out manuscripts to sources to check for accuracy. We were always very careful to say, this is not an approval stage. We are not expected, if there are things about this, basically it was your caveat to make sure that they knew it was technical accuracy. And for the most part, I found sources, that's all they really cared about. And so I've never understood the reluctance, and I've never understood the reluctance of magazines to share that, because I've not had negative experiences with people trying to mark up the copy, or else if they have had a few negative experiences, it's definitely been in the minority. And as a freelancer, when I work for someplace else, I'm fully aware I'm not the expert, and I want them to look at it, because sometimes it's not just the individual fact. Sometimes it's the context of the proportion, or is something subtle, or some omission or something. And I've almost always found that a review process, whether it was this personal review process, which I do as a matter of policy myself, or also an external review process, is almost uniformly beneficial. You can always ignore the result of the remark.
Right.
I mean, for me, I'm in TV, and for me, a lot of it is it's time and headline, and it's usually not built into the process. That period of brand of that you can't control.
Mm-hmm.
So it's I don't know.
Have you found that to be deleterious with accuracy levels and things that you've broadcasted?
Well, no, because most of my work is at National Geographic, where you do build. There's a time where I give it over to researchers who do. It is their job to find the three facts that go along. I give them one, and they have to find two independent sources. So it's built in, but yeah, it depends. It depends how it's structured, because this is a really out there example, and it's not in astrophysics. It's in the human body, and so it's a matter of editorial control. If it's done for accuracy, then there's no problem. But accuracy can be lengthened. I did a segment on this human body show. I did a piece with Stephen Tyler, Aerosmith, and contractually they had the rights to review my stuff before it went out. It was supposed to be for accuracy. We basically put a probe down his vocal cords, and we have his vocal cords vibrating to dream on, so we can see this. And we went to a concert, and we were filming In and Out, and him from inside and out. But the review ended up being about his bald spots more than it was about anything that we said wrong or right.
What? And they forbid you to use a certain camera angle?
They forbid. Not only did they
And-
camera angle, they forbid an audience member who might have been older than the demographic they wanted to show.
But did you have a prior contractual agreement with Aerosmith?
No.
So why did you feel compelled to respect that?
Well, in this case, they actually took the footage. So it was they held all the cards.
Okay. Well, that's a different kettle of fish.
Obviously, it's a really extreme example, but you know, that review, me waiting for Steven Tyler's phone call, you know, caused me a lot.
So bottom line, keep Steven Tyler out of science stories. Okay, let's move on.
But like, I mean, it's so hard to have that time, like you were saying.
Yeah.
Like we are expected to turn out a copy as
The news cycle is just so dizzying now. I agree.
And it's like with, obviously there are a lot of competitors as well. Like you want to get your story, especially if it's like something that everybody else is going to have. You want to have it first, or you want to have it before.
Yeah, but you also.
But the reverse is also true.
It's true. It's true. But it's like some editors, they would rather have a shorter, less well-researched thing first than something better later. It's who you deal with.
Mm-hmm.
And part of this is acknowledging that we do this because we love it, but also because the problem is it's a business. And we have almost the reverse problem at Sky&Tell. We tell ourselves, yes, our story is going to be maybe 2 days later than everyone else who covered it, but we're going to take more time. And this is how we make ourselves feel better about the fact that we are not putting the news out when everyone else is. It's because our story is better. But when the hits come in at the end of the week for web traffic and the publisher goes, why aren't our hits high enough? We need to get it higher. Then we're faced with this issue of, well, we stand up to them and say, we have standards that we are going to meet, and you know what, your goals, heck with them.
Their screen time is longer. They're reading. They're staying on your screen longer.
And
Seeing the ads longer.
it also can affect you as a, I have not had any experience that bad, I will say. But I recently was writing a feature where I really wanted the researcher to read over it because I felt totally out of my depth, and I sent it back to him for accuracy check. But his wife had just had a baby, so he had a lot of things on his plate, and he didn't get it back to me when I thought he would, and I had to delay turning it into my editor by a week, which meant it's been pushed back 2 months in publication from when I originally thought it was going to be. But that it's the question of, can you make that decision personally as a journalist?
Right.
Like, I am okay taking business hits, taking whatever hits you're getting because you care about the accuracy.
Right.
And I personally was handsy with it.
Can I just add to that? Because I'm a freelancer, and so I have to make a living, and that involves selling stories. And I do my best to be accurate. I do my best to double check it, 5 times check what I'm writing and pitching. But it's really hard to be able to say that, because if something is held back 2 months, I don't get paid, maybe at all, if it gets killed, or I get paid 2 months later, and that was a story that I had built in because I need to make sure I have enough money for rent and whatever else. So it's a different kind of.
Yeah, I mean, as a freelance, you almost have to do a cost-benefit analysis with frequency of work, payment, but also your reputation as a journalist has to be a major weight on that seesaw, if you know what I mean.
And it can be really hard because if I'm writing for the web, like that Kraken story,
Yeah.
I had to write about that. I got to sign that story, and I hated that story. It was horrible. And people are going to read this and like, who is this idiot covering this with total lack of, bullshit meter? But I had to write about it. And it was because it was kind of, I did it in a way that was like, look at this bizarre thing, isn't this funny? Or, I tried to like take a different angle on it.
Yeah.
But I really worry about that kind of stuff affecting my reputation, my credibility as a journalist. And I have to balance that with needing to pay the bills. It's hard.
My question is about skepticism again. What do you think about the coverage of the recent opera experiment? Neutrinos traveling faster than light?
Yeah, I had no problem with that coverage. Okay, so the question was, what was my opinion of the recent media coverage of the opera results of purported faster than light neutrinos? I had no problem with that coverage because it was the scientists themselves who were saying, there's something going on here that's probably not right. Let's figure it out as a community. I don't think any of the coverage ever said explicitly, scientists have found particles that move faster than light. It was always put in the context of, this is a mystery that they're trying to figure out. If it is true, it would mean X, Y, and Z about general relativity and so on. But that issue of scientific community self-examination was in every story that I saw. So I didn't really have a coverage, but maybe I'm
a lot at our place in San Diego, and I talked to dozens of scientists. We thought that the journalist coverages, that was good. We did not like what the Oprah team did and what CERN did, but we thought that most of the coverage was very accurate. And in the end, did it really hurt science? I don't really think so, because people were thinking about this. The people paid the price in the end for their stupid, for pushing it forward. So
Yeah.
I thought that was a good moment for science.
I agree.
That was kind of my perspective to a certain extent. Twice as many people now know
What a
the
new
word.
treatment is.
And so where does that play into
Right.
it attracting people to the word, and then they'll look at
Yeah.
the next article about computers.
Yeah. Joel.
Let me tell you what really bothers me, and I think virtually all scientists about this kind of story, which wasn't the case with the opera neutrino fast and light story, but it's happened with other stories even quite recently. That is when some purported discovery gets front page coverage or really extensive web coverage. And then when the more recent, better understood results come out, if they get any coverage at all, it's back page. And so people constantly get the idea that we scientists are a lot less careful than most of us actually are. And of course, all this issue that you've been talking about deadlines and wanting to get there first and so forth, is part of this. Let me give you an example. There was this recent story that was about an article accepted for publication in Astrophysical Journal about new data on the distribution of stellar velocities near the sun in the Milky Way. The article presented the data and then presented an analysis of the data that claimed that the implication is that there's virtually no dark matter in the vicinity of the sun in the Milky Way. Moni Biden, I think, was the name of the last name of your first author of the article.
Right.
And this got a huge press release from the European Southern Observatory, which I think they figured was okay because it was accepted for publication in a very prestigious journal. The problem is that the analysis was completely wrong. And this was pointed out a few weeks later, about a month later, in a really definitive article by Jovi and Tremaine. Scott Tremaine is the master of the field, the author of the leading textbook, the head of the astronomy program at the Institute for Advanced Study in Princeton. And what he showed was that the assumptions that the Chilean article made lead to obviously absurd conclusions. And they simply had made a really stupid assumption that anyone, sort of a theorist, would realize was completely crazy. They weren't theorists, they were observers who had gone beyond their own expertise, and they somehow got it past the referee. I subsequently found out that the referee, in fact, had accepted the article thinking it was almost certainly wrong. In any case, the problem is that this got a lot of coverage. And when the Jovi and Tremaine article came out, they didn't bother with press releases. Widely, I mean, everybody in the field knows.
Yeah.
I just pulled that story off the muy interesante. I mean, this morning I called Madrid and I said, stop it.
So Dennis
You're
Oakley
coming?
and Robert Nye from the Stein Telescope asked. And you know, they didn't cover it because they smelled that there was something wrong.
Well,
and very quickly we could explain what was wrong. But a lot of places that weren't as careful, the Stein Telescope, for example, or the New York Times, gave a lot of play to that story, which is okay if they would also give play to the fact that it was wrong.
Of course.
But they never do.
Yeah, but how would you know?
I know.
That was what.
But I just
No,
want to
if you
tell
have
you
something
that's
like
what
that.
really
Go.
frustrates us.
Let Lisa go.
Yeah, from our
and then
perspective,
Earl.
we get a press release that says, here's something interesting. So I covered both of those because I happened to see the other one on the archive. I was like, shit. I was one of those less careful people. I asked an outside dark matter expert who was like, I don't know, sounds reasonable. I didn't ask someone who does stellar velocities because I wasn't thinking. And I wish I had, but then I also wish that once, you know, if you have something like that, there's no retraction system for press releases. So you need to, you know, I really wish Bovie and Tremaine corrected their own stories.
We don't need knowledge making press releases.
What?
Well, that's partially the responsibility of the folks at, is Tremaine at Princeton or IAS? I mean,
He was, of course, at the astronomy department at Princeton, but then he became the head of
that's where good institutional news officers need to come into play and say, hey, this got a lot of attention. On the flip side, you guys are showing X, Y, and Z that it's wrong. That's a valid reason to put out a news release for the community of people who wrote about it in the first place. I agree wholeheartedly with Lisa's point. Earl?
Yeah, well, I think we hold the distinction of being the only research institution that's actually put out a news release that said, I know that there's been reporting that our prof has said X, Y, Z, but it's BS, and that's not the way science is done. We've done a couple of those in the past, but the real point I wanted to make was, in Joel, with all deference to the frustration, which is understandable, and I've heard for 40 years, you got to remember, news is a dirty business. I mean,
It's the first draft of history.
It's history called on the run, Ben Bradley's statement on the thing. And the wonderful thing about that is that we can change it within the next news cycle. Of course, news cycles don't exist anymore, but we can change it if the players want to be accurate in the line. There is a responsibility for institutions to follow up and correct when things have been done. The problem is that those decisions are usually done by leadership that does not have a good grasp of the day-to-day operations of science, does not interact with some of their own scientists and the like. And that's a fundamental dilemma of comprehension, of understanding what ought to be done. But I mean, the problem I have with investigators, and I've interviewed thousands of them in my day, is the expectation, is the lack of understanding of what the news process is and what the role of journalism has in that thing. I've told students and I've told professionals for years, if the resulting story is 70% correct, you ought to take that to the bank. Because ultimately what you're looking at, I argue as a journalist and as a press officer, you're not looking at that story. You're looking at the 10 or 12 stories you'll be doing after you establish your relationship with this source and you're clued in, you get this free education in there, you whatever ology you're needing. But I think that's really a key thing.
Yeah, and I would say, I have two things to say about that. One is, for this meeting in the future, I think this session should happen midway through the meeting so that all of the scientists are still here. Because a lot of the things that are being said right now are so important for them to hear. I'm glad Manoj is still here to hear this, but almost everyone else isn't. Second thing, Joel, just for perspective or just to keep this in mind, just be glad that you're not in the business of studying the benefits of certain breast screening technologies or the benefits of red wine for whatever. Because there, readers get ping-ponged all over the place every 6 months, and that's directly affecting people's lives. Okay? The prevalence of dark matter particles in the solar neighborhood, as you yourself said, does not directly affect people's lives.
Just to pass the buck on that issue twice, first, as I think Earl pointed out, it's sort of a problem with journalism as a whole rather than just science journalism. That the dog bites man story is always going to be more interesting than the man bites man. Right. You know what I mean. But anyway, the surprising finding is the headline and the story that's, well, things really were what you thought they were it's hard to sell to your editors, but also from personal experience, when I write those stories, nobody reads them. When I say, well, that habitable exoplanet we wrote about probably doesn't exist. 200 people read that story, and I wonder why I even bothered writing it in the first place.
I mean, that happened here at UCSC, where there was a purportedly habitable exoplanet that virtually no one else in the community believed. And it's almost certainly wrong, unfortunately, and it's going to feed back on the reputation of this particular researcher and colleagues, but it got a ton of coverage. There wasn't any, there was some, but not a lot of follow-up coverage. Yeah. Gleesa something or other.
So we have the ability to go to things like OAS, again,
I think.
I know with time that does happen, but I mean, is there something that you recommend as scientists that I look to find people to comment on, like that dark matter paper? I didn't end up covering that, but something like that.
You have to read the literature. You have to read AstroPH. You have to look at citations.
Yeah, no, I mean I do, but I mean, is there on deadline or when
There's no shortcut. It just takes time. Yeah.
Yeah, that's why. You know what? And we're all pretty friendly, and we're on deadlines ourselves.
Just take calls rather than emails. I get hundreds of emails every day. I'm not that likely to do it. If you actually call and you say, I'm a reporter for so and so. What do you think about that? I might say, well, I haven't read it. If I happen to know about it, I might tell you about it. So just call people.
You don't mind that, really?
What?
You don't mind?
You really don't mind that? Okay.
Be
prepared.
I don't know, but because I don't want to be quoted. I don't want to guess. Lots of times reporters want me to guess the answer, and I'm not. On the basis of what? The reputation of the scientist. If I haven't read it carefully, I don't know.
Also,
Most people
scientists
want to do that.
Scientists care about their field of study. So, if Joel upset with the redshift, likely isn't. Scott Tremaine got upset about this dark matter paper. So he's so upset that he wrote it himself. That's a good one.
So if you can find people who are experts in that same field, and that's where looking at the citations can really help. And you'll find someone who knows it. Who cares? It's easy to give off a 5-minute conversation with someone that doesn't really impact my day.
Lisa brings up a good point, but well, at least I think this is the point you're making, that we're not always aware that that's what people like. I know my policy is I attach a PDF of the paper with the email, or I put a link to AstroPH and say, I'm curious about this particular paper. You may not have seen it yet. Would you be willing to talk to me about it? Can we set up a phone interview?
Yeah, what's that range for you?
Yeah.
Postdocs. Those are people who are not quite so busy, right? Postdocs or advanced graduates.
Okay.
They may be willing to do that more too.
It simply takes legwork and time to build up these contacts. I mean, I had a researcher in Europe who created a new anatomical part for me by email because he was so angry that I sent him a PDF without his express permission first. I mean, so that stuff happens. It's going to be different from one person to the next. But I think it's so important, getting back to what you were saying, Rebecca, first of all, to try to go to meetings. It will pay off in the long run. I think you'll find it to be economically, the return will be there because of the additional things that you'll be able to cover as a result of going to the meeting and finding trend stories in progress. That, for me, was always the most important part of going to these meetings, was mapping out 6 months worth of stories, not just dailies from the meeting. And the other thing is to develop your own set of contacts that go beyond the tried and true people. I got really tired early on in the exoplanet research saga of nearly every story quoting Alan Boss from the Carnegie observatories. He was like the default person for every single exoplanet story. Find other people. There are other people who know just as much as he does, and call them instead. Yeah. It's a routine part of my interviews. Who do you know in the field who is doing excellent work?
And don't forget there are experts outside the US. This is my special tip. If it's the holiday season, then talk to Japanese people who aren't.
Yes, Camille.
My question is actually a little different. I'm not sure if that's going to change. But I was curious about the press office reporter relationship. And part of this is, I know I love a good press release. I'll say that flat out. It's really helpful. But I wonder about how both press officers would like us as journalists interact with them and how we are in our daily work interacting with press officers. I usually just jump over the press officer and talk straight to the scientist. Is that the best way
And Camille, to address another part of your question, I think within the academic community there is absolutely no problem going directly to the scientist. You can get the institutional press officer involved if you need help tracking the person down, if you need multimedia materials that they can help you get, and so on. The issue arises with federal agencies primarily. The DOEs. I mean, within the fields covered here, the DOEs and some NASA, not all NASA. So I can call people at NASA Goddard, Ames, no problem. When I get into headquarters or people who are involved with programs, it has to go through the news officer, and boy, is that a pain. And sometimes they want to listen in on your interviews, and be in the room when you do your interviews. And when they make that restriction, there's nothing you can do. You have to go along with it, or else you don't get the interview.
True.
We only have a couple more minutes, so yes.
I wanted to say to the press officers out there, when you're writing your press releases, nearly everybody get the AAS ones, right?
Yeah.
Yeah. There's been a trend in the last years, I would say, that it's starting to get these really long press releases that are written like a trend story, and they're not in the inverted triangle news format. If you're sending those out, I'm not picking them. I can't figure out why this came in the first paragraph.
Yeah.
We'll know if we get 20 or 30 for written every week, and those magazine style ones.
And if I may, the worst offenders, and I'm sorry about this, the worst offenders are from Europe. Okay, they send out novels that are full of backgrounds, like where's the news, what's the nugget. So apologies, but there are. I agree. Get to the point. Give us a lead. Where's the lead? Don't bury the lead. Yeah.
For me, back to TV, and I'm a TV person here, but we're like down below highlights for kids.
I didn't have. Yeah, I intentionally have not been involved with.
But my biggest challenge right now, yes, there's accuracy in reaching people, but it's honestly it's getting something on the air. Convincing an EP that an hour special on dark matter is important. And I'm competing against on National Geographic quizzing shows and drug wars, and the pressure to have a headline,
right,
and then to synthesize a big story, because I'm only getting an hour or two, out of all these disparate things.
I would say, but in your case, going back to some of the bullet points about the appeal, you've got great narrative. Yeah. You've got incredibly motivated, excited researchers, and you have wonderful visuals. Yeah. So we're all going to be really interested to see what you do with this stuff. But the visuals, I mean, they're the stuff that Sandy.
Animations for an hour.
Yeah, that's right.
Bring them there.
That's right.
And then ultimately the way the data is gotten is looking at something static. It's sewn at a computer. It's a supercomputer. And then there's beautiful animations, but analogies are key. Mm-hmm. Something I can go and film, like a geyser.
A geyser, yeah.
But it's a huge challenge. And unfortunately, a lot of people get their education that way.
Well, we do need to wrap up, but let
me just ask my all-purpose question that I usually ask sources, not journalists. Is there anything important we have not discussed that you feel we should discuss?
Where are the good restaurants?
No, I mean, any issues or anything. I have, yes.
It's related to simulations. So the way astronomy is done is you look at something, you look at radiation, and you tie the radiation to how the radiation might be produced, and then you tie that to the physical processes of what's going on. Now with simulations, you can do it in a reverse way, and that's maybe an easier way to explain to people. You say, this is what we think is going on, and this is how what we think is going on might produce radiation, and this in the end is how we might detect that radiation. And I find that's a more natural way to explain my
it's.
That's up to, I mean, for one thing, you need to understand researchers and the competitors, what they think about that.
Yeah.
How much credence do they give to their own simulations or to their competitors' simulations?
I think, I mean, I think.
You have to decide how much of that fits into your story.
I think you need to have the equivalent of a full disclosure paragraph in your article. It's only doesn't take that much space.
So I've been asked by people, so your supercomputer says this or that. I can program my computer to say that too. What's the difference? So I don't know. That's kind of I think what a lot of the public, when they see the simulation, they think I could write that. You could write anything you wanted to that computer. Why should I believe it? So it's interesting how you deal with that prejudice against simulation.
Well, part of the prejudice from simulation draws from the climate change controversy and what's going on now. I mean, that's one of the shortcomings I would say, Joel, that cosmological simulations are going to have to deal with. The albatross around their neck is all those climate simulations that everybody is discounting now because they don't understand what a simulation is supposed to do. They make that assumption that it's supposed to give a final answer where all it's going to do is give you a picture of what possible situation
Yeah, but
is.
simulations are ubiquitous. Earthquake simulations and financial market simulations.
Exactly.
All kinds of market simulations in the whole data field. And I think people can understand the importance of them. Help us understand, the climate change simulations are, there's a range of quality of climate simulations, but I think a lot of it's really
But if you look at the primary simulations of climate change and take them as a totality together, as opposed to one model for this and one model for that, there's 7 or 8 models that are now used for global weather, and each one of them has very specific strengths in some areas of the globe and very specific weaknesses in others. But the totality taken together, if running multiple simulations run, the answers are much, much better in that regard. But still, that thing, the studies on public reaction on climate change reporting, climate change communications, and the like have shown that the researchers, supposedly the researchers' reliance on simulations is one of the strongest weaknesses. One of the greatest weaknesses of the argument for climate change as it exists. It's a stupid conclusion to have reached, but a majority of the public who have not agreed with the climate change conclusion still give that great
Well,
reason.
let's all just agree that we can keep astrophysical and cosmological simulations apolitical, and that will help a lot along those lines. So I think we need to wrap up, but thank you all for your attention. I really enjoyed this conversation.